Alright, this is Chemistry Goal 6 video notes brought to you by Webster Grove School District for 8th grade science. The goal here is that students are able to demonstrate and provide real-world evidence that mass is conserved during a physical and a chemical change. So in the last goal, you learned what a physical and chemical change are. Now you are using those concepts to apply it to your understanding of conservation of mass and conservation of matter. So, if you're meeting the goal, you are able to demonstrate and provide real-world evidence that mass is conserved during a physical and chemical change. You are correctly applying the law of conservation of mass, otherwise known as conservation of matter, to a situation. If you are above that goal, you are able to predict the result of a chemical reaction using your knowledge of the conservation of mass or conservation of matter. So here we go. What is the law of conservation of mass or law of conservation of matter? Well, if you have not heard of this before, matter cannot be created and cannot be destroyed. Okay, so what that means is there's no more or less matter on Earth than there ever has been. Okay, so unless like meteors or things came in from outer space, but otherwise there's no more or less matter on Earth than there ever has been. Matter cannot be created, matter cannot be destroyed. It just changes forms. It can sometimes change into energy, but it's not going to be created or destroyed. Okay, the mass of an object cannot change even when a physical or a chemical change happen to the object. Okay, so you put an object on the balance, it has a certain mass, you make a change to it, it's going to have the same mass. Okay, as long as all parts of matter are back on that balance. Okay, just a reminder, a review of what is mass. Mass is the amount of matter in an object. Okay, and matter is anything with a measurable volume or mass. Okay, so you need to know the words mass, you need to know the words matter to understand this. Check out the quick video. So these are these magnet thingies, and you can take them apart, you can put them in all different shapes, but the total amount of matter always remains the same. Okay, so the amount of matter does not change here. It's still the same amount of matter. It's still the same amount, even though it changes into all different shapes and all different forms. Okay, kind of cool, kind of neat. I remember these being popular, but you get the idea. Okay, matter changes shape, but the amount still remains the same. Okay? Awesome. Alright, moving on. Next one is about the growth of a plant. Now, for the growth of a plant, we have to think about, where did all of this matter come from? It had to come from somewhere. So the amount of matter that's being added to this pumpkin is coming from the soil, is coming from the water, is coming from any nutrients that are being added to it. And so matter is just changing forms here. It's not that more matter is being added. The matter that was the water, the matter that was the soil or the plant nutrients, is just now changing into a plant. And even if it explodes like that, if we took all of those pieces back, it would still be the same amount of matter. We didn't destroy matter, we just broke it apart into many, many different tiny pieces. Okay? So even if we took all those pieces back, the amount of matter would still be the same. Matter cannot be created, matter cannot be destroyed. It just changes its shape or changes its form. Okay, so then I have a couple more examples. For example, what if a paper airplane is made? Well, same thing. The amount of matter remains the same. Okay, it's just changing its shape from a flat piece of paper into now a folded piece of paper. Well, what if a log is burned? This is a tricky one because it looks like there's less wood there after you burn it. But if you were to take all of the smoke and all of the ash, I mean, think if you burned a log in a sealed room, okay, that room that it was in would still have the same mass. It wouldn't change. Nothing was destroyed. It didn't go anywhere. It just changed its shape. So if you were to take all of the gas and all of the smoke and all of the ash that was now made after that log burned, it would still have the same mass. It would still be the same amount of matter. So when you have a physical change, okay, that would be this one, and when you have a chemical change, the amount of matter still remains the same. Okay? Okay, now let's look at this. This is going beyond the goal. This is surpassing the goal. It says, using the principles of conservation of mass, decide which is the correct product of vinegar and baking soda. So we have our vinegar, we have our baking soda. Okay, definitely a molecule and a compound because it's more than one atom and there are different types in both of these. So vinegar plus baking soda. When we put these two things together, we should still have the same amount of elements on the other side. Okay, so you have to look at this. All right, so how many hydrogens do we have total here? Okay, so hydrogens, we have 3, 4, 5. So we should have 5 total. How many carbons? 1, 2, 3. We should have 3 carbons. Okay, how many oxygen? We should have 1, 2, 3 oxygen. Okay, how many sodium? 1. Okay, so this is what should be on the other side. So then we have to look at our choices. All right, how many carbons does C have? Okay, it has 1, 2. All right, that can't be it because we have to have 3. What about this one? It has 1, 2, 3. Okay, could be this. What about hydrogens? 3, 4. No, can't be it. All right, what about this one? It has 3 carbons. 1, 2, 3. Okay, what about oxygens? 1, 2, 3. Good. What about hydrogens? 3, 4, 5. What about sodium? Oh, 1. So it's A. It has to be A because that has the same amount of atoms as was over here. Okay? So our product here, we have a different precipitate made, okay, kind of salt. We have a little bit of water, and we have some carbon dioxide. Okay? So this is a chemical change, chemical. But mass is still conserved. Okay? And we will do some examples of this in class. If you have questions, please ask. Please write those down and bring those to class with you. Okay? For now, that is it, and that's all. Thank you for watching, and we'll talk to you later.